In this video, we'll take a look at notes in section 9.2, components of vectors. So what is a component? So two vectors that when added together have a resultant equal to the original vector are called components of the original vector. So what does that mean? Okay, so if you have a vector I'm going to think of it as a parallelogram vector. If you use these two vectors and when you add them together, these two vectors when added together have a resultant equal to the original vector are called components. Those are called the components. Okay. So you'll be given the original vector and you want to find the two components. So certain components of a vector are of particular importance. And we're going to take our vectors and put them on the xy plane. If the initial point of a vector is placed at the origin of a rectangular coordinate system, and its direction is given by an angle in standard position, we may find its x and y components. These components are vectors directed along the axes that, when added together, equal the given vector. The initial points of these components are at the origin, and the terminal points are at the points where perpendicular lines from the terminal point of the given vector cross the axes. Finding these component vectors is called resolving the vector into its components. So what does that mean? So our first example, we're given the find the x and y components of the vector capital A shown in figure 911. The magnitude of capital A is 7.25. So the green is the given information. It's an angle in standard position. It's 62 degrees from the x-axis, and the green magnitude is 7.25. So I'm going to label that as 7.25. And what we want to find are the two vectors, lengths x and y, so that if we add them together, we would end up with our vector capital A. So notice what this makes with so the end of this would be actually an xy coordinate. So we're basically finding the length of this side of the triangle, and then I'm going to move the other one over and make a right triangle, and this length of your triangle. So we're given, if I take it out of there, we're given a right triangle where we know the hypotenuse is 7.25, and we know that this angle is 62 degrees. And what we're looking for, I'll label them x and y, okay? We're looking for, in relation to 62, if we want to find the y component, y is opposite, and we are given the hypotenuse. So the trig function that uses opposite and hypotenuse is sine. So the sine of 62 degrees is going to equal the opposite, which is y, over the hypotenuse, 7.25. So to find the side length y, or the vector y magnitude, we multiply both sides by 7.25. And that will give us our vector a sub y. So here we go. Make sure that you're in degrees. So I'm going to check the mode. I'm in degrees. So 7.25 times the sine of 62 degrees. So that equals 6.4. So the length of my vector y, the component, is 6.4. Now we do the same thing to find x. X is the adjacent side and the hypotenuse. So this time we're going to use the cosine of 62 degrees is equal to the adjacent side, which is x, divided by the hypotenuse, 7.25. Multiply both sides by 7.25. And that will give us our, I should put a subscript x. Okay. So now I want 7.25 times the cosine of 62 degrees. And I end up with about 3.4. So those are the x and y components of the vector A. So they're not only these lengths in the triangle, it's actually the coordinate at the terminal side of your vector A. It actually lands right here at the point 3.4, 6.4. All right, so that's in the first quadrant. What happens if your vector lands in a different quadrant? So next example, we have a surveyor's marker is located 14.4 miles from the set pin at 126 degrees standard position angle as shown in the figure. Find the x and y components of the displacement of the marker from the pin. So this time we're given that the pin starts here and rotates 126 degrees. So we have our green vector. And that we also know that distance is 14.4 meters. What I want to find is the x and the y components of that 14.4 meter vector. So we're making a right triangle. Use the reference angle 54 degrees. Drop a right triangle to the x-axis. And then now along the bottom, this is our distance, our x component, and then our y component. And the angle that we know, 126 degrees, the reference angle is 54 degrees. So now we're going to use right triangle trigonometry to find the lengths d sub x and d sub y. All right, so we have 54 degrees. We have the hypotenuse. And from 54 degrees, this is the side opposite, the side adjacent. So to find d sub x, we're going to use, let's see, adjacent hypotenuse is cosine. So the cosine of 54 degrees is equal to adjacent over hypotenuse. Multiply both sides by 14.4. Okay. I'm going to set up the other one too, and then we'll put it in the calculator. So to find y, the component y vector along the y-axis, we're going to take, let's see, opposite hypotenuse is sine. The sine of 54 degrees is equal to our y component divided by 14.4. Multiply both sides by 14.4. That equals our y component. So one thing to notice though, if you're in the second quadrant, the x-coordinate is negative and the y-coordinate is positive. So our x-coordinate, when we find this 14.4 times the cosine of 54, has to be negative because in the second quadrant, our coordinates are negative x, positive y. So I take 14.4 times the cosine of 54. We get a negative 8.46, or about a negative 8.5. And then we take the same 14.4 times the sine of 54. And we end up with about 11.65 positive. So the coordinate where this vector ends would be the coordinate negative 8.5, 11.65. So depending on what quadrant you're in, your component vectors will be positive or negative. All right, last example. Resolve the given vector into its x component and y component. The given angle theta is measured counterclockwise from the positive x-axis in standard position. So now I know that my magnitude is 2.34 and my angle is 247.41 degrees. So let's see, I know that this is 0 degrees, 90 degrees, 180 degrees, 270, and then back to 360. So 247 is going to be in the third quadrant. I'm going to go ahead and draw my vector. And my vector is 2.34 is the magnitude. So what I'm trying to find is the two resultant vectors. Okay, so I'll use x d subscript x and d subscript y again. Oh, they're using a's, so I'll use their notation. A subscript x and a subscript y. So basically we're going to find the x and y coordinate. Notice we're in the third quadrant, so both of those will end up being negative. All right, so I want to draw a right triangle. Drop it down here, and I'm going to take that kind of out of the picture over here, draw the right triangle. I know the hypotenuse of my right triangle is 2.34, and I want to find this angle. So I know that it's 247 degrees to here, and I need to find it between 180 and 247. So we take 247 minus 180 degrees, and that gives me, what, 67 degrees? So this angle is 67 degrees. So using that as my angle, and I'll label my sides, 67, the side opposite 67 is the y component, the side adjacent is the x component, and I've got 234 as the hypotenuse. So to find a sub x, I'm going to use adjacent hypotenuse. I use cosine again. So the cosine of 67 degrees is equal to opposite or adjacent a sub x over hypotenuse 2.34. And if you notice, we keep using cosine every time for the x component. Then to find a sub y, I need to have opposite and hypotenuse. That's going to be the sine. Over the hypotenuse of 2.34. Multiply both sides by 2.34. Equals a subscript y, my y component and my x component. They're both going to be negative because they're in the third quadrant. So we type those in our calculator. I need 2.34 times the cosine of 67 and 2.34 times the sine of 67. So my x component ends up being a negative, let's see, we want the nearest hundredth, negative 0.91. And my y component ends up being a negative 2.15. And again, it's because they're in the third quadrant. My angle ended up, XY coordinate ended up in the third quadrant, and they're both negative.